Hello guys, welcome to Bugs in Code. The problem that we are going to solve today is unique paths in a grid. But before that, if you are new here and a person who likes stuff related to coding, then you can subscribe my channel so that you never miss out an update. So let's get started. Okay, so here's the problem statement, and it says that you're given a matrix grid of n cross m size consisting of values 0 and 1. So it's basically a binary matrix. A value 1 means you can enter that cell, and 0 implies that entry is not valid, like it's a no entry. You can start at the upper left corner. Okay, so you should start from the upper left corner of the grid, and you have to reach the bottom right corner, that is the last corner, such that you can only move in the right or down direction from every cell. Okay, your task is to calculate the total number of ways of reaching the target. Okay, so let me explain the problem statement. So let me take a grid first. So I'm going to take a 3 cross 3 size grid. So this is the grid, and let me move this grid here. So this grid is basically going to have values like 1 1 1 1 1 0 and 1 1 1. Okay, so for this grid, what I can do is I can move either in the so what I can do is I can either move in the down direction or I can move in the right direction. So what I'm going to do is I'm going to what I need is actually I need to find the total number of ways to reach from this point. We have to reach this point, so this is going to be our target, and I have to tell the total number of ways. So in this problem I can see one of the way is go here, then down, and then right. So it is basically going to be right, down, down, and right. So this is the first way, and the second way that I can notice here is down, right, down, and right. So it is basically down, right, down, and right. Okay, now the third way that I can have is down, down, right, and right. So it will be down, down, right, and right. Let's see, is there another way? So if I go right, right, and down, then this is something which does not allow any entry. So okay, so there are total three ways, and three is going to be my output. So this is about the problem statement. I hope you guys got the clear understanding what the problem actually says. So now let me, okay, there is one more thing here, that we can have the target value very large, so we need to return modulo 10 raised to the power 9 plus 7. Okay, so here 1 1 it is basically one based indexing, where 1 1 represents the first cell, and the last cell is basically represented by n comma m. Okay, so let me move to the solution here. So what I can do here is, let me draw that matrix again. So I'm going to have a 3 cross 3 matrix. Let's move this matrix here. Okay, so let me draw it again and move this matrix at this point. Okay, so I'm going to store 1 1 1 1 1 0 1 1 1 in this matrix. So what I can do is I have to start from there is no doubt that I have to start from this cell, and I have to reach this cell. So what I'm going to do is I will have a function which will start from this 0 comma 0, and after that I'm allowed to take two moves. So what I can do is from this point, like 0 comma 0, I can either move to 0 comma 1, or I can move to 1 comma 0. So it is basically representing a right move, and it is representing a down move. Okay, from this so it is the uh, 0 comma 1 cell. Okay, so it is 1 comma 0 cell, and it is 0 comma 1. Now from this cell, like from this 0 comma 1, I can either move to 0 comma 2, or I can move to 1 comma 1. So it is again right move, and it is the down move. Okay, now from this 1 comma 0 I can either take a down move. So for this 1 comma 0 the down move is 1 comma, okay, so the down move is 2 comma 0 and the right move is 1 comma 1. Okay, and we can even see here that for the this one, our down move is 2 comma 0 and our right move is 1 comma 1. So it is the right move and it is the down move. And for this 0 comma 1 our down move is 1 comma 1 and our right move is 0 comma 2. Now from the 0 comma 2 I have only one option, that is going to be 0 comma that is going to be 1 comma 2, and at this point I have a value which is 0 and this value doesn't allow any entry. So what I'm going to do is I'm going to move a point which is going to, which is not allowing any entry. So this is the point, and from this 1 comma 1 what I can do is I can have another move which is, let me zoom this, okay, so now what I can do is from this 1 comma 1 I can have a move which is the down move. So the down move is, okay, so let me first take a right move, and the right move is going to be my 1 comma 2. So this is again the move which is not allowing any value, like it is a 0. After that from this 1 comma 1 I can have a down move as well. So this down move is basically 2 comma 1. Now from this 2 comma 0 I can make again, okay, so from this 2 comma 0 I can have only one move which is right move, isn't it? So the right move is going to be 2 comma 1, so I will write here right move. And from this 1 comma 1 I will again have okay, similar to this, like right move which is not allowing any value, and the down move which is basically going to be storing what, uh, 2 comma 1. Okay, now from this 2 comma 1 what I'm going to do is I'm going to move to the only right option which is my 2 comma 2. So it is right move and 2 comma 2, again right move, and the right move is here 2 comma 2. Now this is our target, so let me highlight this. So this is our target, and when we have reached our target, then what we are going to do is we are going to return a value which is 1. So this function will return 1, and the point which is not valid is going to return 0. Now from here I am going to return 1 and here I am going to return 0. When I add these two, then I get a value which is 1. So this one basically represents that from this cell I have only one way to reach the target, like which is going to be here and here. So this is something which is represented by this one. Okay, now this 2 is also going to return 1. It will return 1 and this will also return 1. Now this will have 1 and these both are going to return 1. So here the output is going to be 2. Now what this 2 represents? This 2 represents that from the cell 1 comma 0, from this cell I have two ways to reach this point. The first way is going to be this way, and the second way is going to be uh, let me remove this, and the second way is basically going to be this way. Okay, so now let me again move to for this we have one value and we are going to again return 1. This is going to return 0, this will have 1 and it will return 0, and 0 will come here. After that 0 plus 1 1. So for this 0 comma 1 I have one way to reach the target, which is down, down and right. And when I add these two, then I get three ways total. Like what are the ways to reach the from this? Okay, I want to clarify this thing. So from this starting cell I can either move to this cell or I can either move to this cell. So if I get anyhow, if I come to know about how many ways are there to reach the target from this point and how many ways are there to reach the target from this point. So I will get to know by adding these two values. So my answer for any I comma j is going to be my answer for I comma j plus 1 plus answer for I plus 1 comma j. Think about it. Isn't it right? I have given you the total intuition like how it's actually working. So this is what we are going to have. Now what we are going to do is I want to write here what are the ways. So from this I have taken a right move. After that, so if I talk about this, so I have taken a right move. After that I have taken a down move. uh, After that I have taken again a down move. After that I have taken a right move. So if I write right, down, down, right, which is this, from this one I can take a right move, down, down, and right. So this is one of the ways. After that, another way that I have is take a down move. After that, take a again down move. After that, take right move and take right move. So the second way is down, down, right, and right. And the third way is going to be down. Okay, after down, take right, then again down, then right. So down, right, again down, then right. So these are the three ways to reach from starting point to the bottom right point, which is the target. So the output is going to be 3. So from this whole structure you can see that this problem is basically a recursive problem. So it is a recursive problem, and what we can do is we have a recurrence relation which I have written here, and now we are just going to implement this. So let me implement this approach. So this is the problem on Geeks for Geeks, and I'm even going to provide the link in the description box. So let me just define a mod first. So mod is going to be 1e9 plus 7. After that, what I'm going to do is I'm going to have a function which will have a variable that is 0 comma 0. I'm going to start from 0 and I will pass another parameters as grid size. Now I will have this function. Okay, so now I'm going to write the conditions as I have explained with the diagram. The first condition was, what if my I is greater than or equal to n, or my j is greater than or equal to m. So these are the boundary points, like if my I or j becomes out of the boundary of grid, then I need to return 0. Then I need to return 0. But there is one more condition. One more condition is, if my grid the element of the grid is 0, at that point I also need to return 0. Let me take one more case which is very important, like what if I have reached the target. So if I have reached the target, then I am going to return nothing but 1, which I have explained in the diagram of the recursive flow. After that I am going to return the answer for the right option and the down option. So I will have, first I am going to go down. So this move is basically a down move, because why? Because I'm just incrementing the row. After that I will have a right move, which is this. So this is basically the approach, and let me just run it. But before that I'm going to calculate mod here, and I'm even going to take a long function. Why long? Because a long basically helps us to cope with the overflow error which we see in the integer format. Okay, so let's see, it's showing mod is basically not defined as an integer. Now I think it should work, and let's see. Okay, so it's working for the example test case, and let me just submit. So it is going to give me time limit exceed error, there is no doubt. But this is the recursive approach. I have just given you the idea. Now let me move to the another approach which is going to be very interesting. So I want you to notice that this problem is something which is following the uh, like what we call, I'm not able to recall exactly, when we have, I will call it a basically it is following a optimal substructure. So here the solution to the main problem is depending on the solution to sub problems, as we can see with this recursive relation. Now one more thing that I want you to notice here is this case and this case. Are you understanding what are these cases? These cases basically representing the same problem, and I can conclude that here I have one thing which is, let me just zoom it out, and I'm going to move it here, and I'm going to write here something. That something is, I have overlapping subproblems, isn't it? I'm solving two problems again, like for this 1 comma 1 and this 1 comma 1. Of course this is a right move for this and it is down move, but it doesn't matter because in the function we have only I and j as parameters. So in order to solve this problem we are going to use a very interesting concept that is known as dynamic programming. Okay, so dynamic programming can be implemented in two ways. So when we have already written a recursive function, then we can apply something that is memoization. What we do in this approach is we basically create an array and try to store the solution for sub problems which are already solved by us. So let me just implement this, and let me just implement this memoization based approach. So what we are going to do is we are going to have a dp array. What is the size of dp? Let me ask from you. The size of dp is going to be n cross m. Why? Because how many subproblems you can have, since we have two changing variables I and j, so the total number of subproblems that we can have is I cross j. So I need to store all these subproblems in a matrix. So in order to hold all these subproblems, I need a dp array of n cross m size. So it is basically a 2D array. Now I'm going to store the subproblem for the solution for all the subproblems here. Let me just make it mod, and I'm going to store here dp of I comma j, which means solution for I comma j is here. Now if I have already the solution for a particular subproblems, like dp of I comma j is not equal to null, I mean dp has some value, so it means that we have already solved that problem and we are just going to return the answer. Let's see whether it works or not. So I think it should work, and it may have compilation errors. So okay, it's working for example test cases, and let me just submit it. Okay, so it is working, and this is all about this problem. And let me just move to one more interesting way to solve this problem, which is the tabulation based approach. So let me explain it here. What I'm going to explain is you may have seen videos which just explain either memoization or tabulation, but this video is something which is a package which explain the whole intuition, like how we move from the recursion to memoization, and after that we come to tabulation. So but you may ask a question that if we are done with the memoization approach, so if we are done with the memoization approach, then Why tabulation? Why tabulation, man? The tabulation because this memoization approach is basically which is implemented on the top of recursion. So this means that this memoization also using, so memoization uses extra stack space. So in order to avoid that usage of stack space, we are going to use the tabulation approach. So I'm not going into deep, I'm just giving you an idea. So let me just move to the tabulation approach, and what we have in our matrix is we have a matrix which is a 3 cross 3 matrix. So let's move, okay, so let's move it here, and we are going to fill it with 1 1 1 1 1 0 and 1 1 1. After that we are going to have one more array which is going to be our DP array. The size of DP array is obviously going to be same as the given grid, because the DP array is going to have the same number of subproblems. So for this, my question is, for this, if I'm at this point, then how many ways are there? Obviously there is only one way, because from this to the reach the same point there is only one way, which is I'm at the same point. After that, if I'm at the 0, then from this there are 0 ways to reach this point. After that, from this 1, since there is 0 between, so there are 0 ways. So and what I'm going to do is I'm just going to look in the down. For this I have only down option, there is no right option. So I'm going to look down, hey, can you help me to reach this point? So it's a no, I can't help you, man, because I'm it's a 0. But what about these values? For these value, if I see here, then here I have 1. So this one can help me to reach this point in just one way, because it is storing 1 and I have only option to move right. After that, similarly I have this as 1, and this is going to help me to reach this point in one way. Now for these values, so this is the pre-calculation, because these values are now going to help me to solve the problem for this. How? I will start moving from this point. From this point I will check, since I have both the moves, I have right move and the down move. So what I'm going to do is I'm going to ask from the right cell as well as the down cell, hey, can you help me to reach the target? So it says when you move right, then you cannot reach the target because it has the 0 value, but when you move down, then you can reach the target. So it is going to have this sum of these two, which is going to be 1. So I have one. From this point I have one way to reach the target, which is down and right. Okay, now for this point, when I move right, then I have one way to reach the target. When I move down, similarly, I have one way to reach target. So the total number of ways for this is going to be 2, which is sum of these two values. Okay, I hope you guys are getting the intuition behind the tabulation. And now similarly for this, uh, say since we have 0, okay, I was writing wrong here, we have 0. Okay, so now when we add these two values, then we get 1 for this particular cell, which is down, down and right. Okay, now for this cell I can either go right and either go down. So I have total number of 3 ways to reach the target. So this is how we are going to reach our answer, and at last dp of 0 comma 0 is going to give me the answer. Okay, I hope you guys got the understanding of the tabulation based approach, and let me just now code this approach. Let me reset this code and let me start implementing my tabulation based approach. So I will have a static in mod which will be int. Similarly, I will have a DP array. Now I'm going to initialize my DP array as when I implement these approaches, then you should keep your notes, keep the notes that I have made to somewhere in your copy so that you can relate what I'm typing while implementing the approach. So first of all, what I'm going to do is, okay, so it should be basically a long. Now for the dp of for the this particular cell I am going to store 1. Okay, so let me write here dp of n minus 1 and m minus 1 going to be 1. After that I'm going to do pre-calculation for the last row. So I'm going to start my column from m minus 2 and column is greater than equal to 0, column minus minus. After that my dp of last row and the current column is going to be dp of last row and current column plus 1. But this is only when our dp of I and j is not equal to 0, and if it is equal to 0 then I'm going to store 0 on my dp of I and j. So dp of it is basically going to store 0 in the long form. Similarly, I will do the calculation for my last column. So I'm going to start from n minus 2 and I is greater than equal to 0 and I minus 1. What we are going to do is we are going to check if my dp of I comma j is not equal to 0. Then only we are going to do dp of I and m minus 1 is equal to dp of I plus 1 and m minus 1. Okay, else my dp of I and j is going to store 0 long. Okay, now what I'm going to do is I'm going to do the calculation for this particular part, like for this part. So let me do it and let me just write the code. And for my column will start from m minus 2 and column will also be greater than equal to 0 and column minus 1. If my dp of I and j is not equal to 0, then my okay, actually it is not dp. I'm writing here it should be grid, and grid of I dp of ij is going to be dp of I plus 1 j plus dp of I j plus 1. Obviously because I can have either right move or the down move, else my dp of I and j is going to store 0 in the long format. At the end I will surely have my result in the dp of 0 and 0. So I'm going to even do the mod, and here I'm going to, in order to avoid the overflow. So this is the tabulation approach. Let's see whether it works or not. It may show compilation error, so let's see. Okay, it is showing, it is at line number 47 it is showing, because there should be n minus 1 and I here. Similarly I and it should be n minus 1. Let's see now, is it working or not? Okay, so it's working for the example test case. Let me just submit the solution. Okay, it's showing the problem somewhere. Why? Because okay, let me check one more condition which I'm not writing, I don't know why. But if my last element of the grid is 0, like m minus 1 and m minus 1 double equal to 0, then I need to return 0. So this condition is very important, and even this should be for the first element as well, but my code is already doing it. So let me just even write for the first element. Even if my first element is 0, then also I'm going to return 0. Let's see whether it's working now or not. Okay, it's showing compilation error. Okay, it's working. And okay, so the solution is all correct. Now about this problem here, I have explained three approaches to you. Basically the tabulation approach. I started with the recursive approach. uh, the recursive approach is the recursion tree, which is very important. Like, this is a recursion tree, and after that I moved to the memoization, and after that I told you the tabulation approach. So this is all about this problem. I hope you, if you guys like the video, then you can hit the like button. So this is all for now. Thank you.